Hi everyone, welcome to the channel. Today we're going to create a fully procedural and interactive flower blossoming system inside Houdini. So let's actually take a look at what we are going to be creating. Okay, let's start by creating new geometry. And inside this geometry, let's create a grid with the size of 1 by 1. And then let's scatter a couple of points here, maybe 10 for now. And now let's draw up a wrangle node. And in this wrangle, we are going to implement like all the logic to create the lines of the flowers. So first, we need an integer array. Let's call it PTS. This will store all the points so we can reference them later. And now let's create a step, like a resolution of our lines. So float y step, and let's make it equal to float channel y step so we can control it. And yeah, we can already apply some randomness to this, so let's multiply it by a random number. Let's put ptnum as a random generator, and yeah, something like that. And next, let's create a resolution parameter, so this will control the distance between lines as well. So let's call it res, and let's make a channel, float channel called res for resolution, and let's multiply it by 100. So now if we click this button, we have those two parameters. So maybe let's set this y step to 0.01 for now, and the resolution to 0.2 maybe. You won't see anything in the viewport for now because we are not doing anything with those values yet. So now we want to like sort of iterate on every of these points, and we want to create the lines that go on the y direction. So we are already iterating over all the points. So inside this code we need another loop, like so we can type for loop for, let's create an integer I equals 0. The condition will be if I is less than the resolution, and increment by 1 after each loop. So inside the loop we are going to create a float called offset, so float y offset, and this will equal to I times multiplied by y step. So in every loop we'll be incrementing this y offset. It will be equal to I multiplied by the y step. So at 5 it will be like, you know, a little higher, at 6 even higher, and so on. So now let's create another float called y pose, and let's assign it the value of v at p. So y component of position plus y offset. And then we can create a vector variable called pose, and let's set it equal to, we need to construct a vector here, so let's use a set function, and let's type v at p.x. So we are taking the x component of current position, and for y we are taking the y position that we've already calculated above. And for the z, we are taking the original position of the point, so v at p dot z. And next we we need another integer, so integer pt, and here we are creating a point at this point. So at this moment we are creating a new point, and inside this pt variable will be stored like the ID of that point, so we can reference it. So if we type at point 0, and we want to create this point at the position that we already created above, so now we can, you know, reference this created point by taking this variable. So that's it. So now we are ready to append this new created point to our array that we created right here at the beginning. So append point, and now we can create a line of it. So at prim 0 we want to create a polyline, and the first point will be the point that we already created, so it's pt, and the end of line will be like the previous point from the array, so pts, and we're going to reference it by index, so I minus 1, something like that. And we have some error here, identifier, oh yeah, here we need a semicolon here. So right now you can see we created these lines, and we can easily control them here. Maybe we can even, you know, remove this for now, this randomness. So every line is equal. We'll create the randomness at the later stage, so you got the idea how it works for now. And now let's go to the next step, which is controlling these lines. So let's create a new float called ny range, which stands for normalized y range, and we are going to use a fit function. We're going to fit the y offset value, which goes from 0 to y step multiplied by resolution, and we want to map this value to go from 0 to 1. So that's it. And now we want to create a new point attribute. So set point attrib, and here let's type a 0. We want to call this new attribute y range, for example, and we want to apply it to the pt point, and the value will be normalized y range, like this. And now let's create another point attribute. So set point attrib, and here let's create a y max attribute, which will specify the highest y value of the current line, of the current flower particularly. So we want to apply it to the point, and the value will be like resolution multiplied by y step, like this. And then we can specify another integer, which we are going to use at later stage to, you know, to differentiate that we want to use this specific point for like the root of the flower, the core, to attach the leaves to it. So let's call it is stop, and let's assign 0 to it for now. And here let's use a if condition to change this value. If I equals to res minus 1, so if you are at the you know end loop, at the last loop of this iteration, we are going to change the isTop to 1. So isTop equals 1. And here let's create a new point attribute, set point attrib 0 isTop pt, and the value will be isTop. Okay, so now if you go to the geometry spreadsheet, you can see these values right here, and you can see that isTop, we have some points, only a few of them. The number of the points that have 1 value of the isTop will be equal to the points scattered on the plane. So 10 points have the value isTop equals 1, and the rest is 0. And y max and y range is like a self-explanatory here. So now we can go to the next step, which is like bending these lines. So let's create another wrangle node, and inside this wrangle let's create a new vector called target pose, and let's make it equal to the point attribute of the second input here. We're going to connect something to this in a moment, but for now let's create the wrangle here. So first input, we're going to take a position of the point 0, and next we are going to create another vector. We can call it xz to target. xz, which stands for xz direction to target. So we're only calculating the direction on the xz plane. We're not taking the y value in calculation here. So that's why I applied xz at the beginning. So let's make it equal to target pose minus v at p, and let's multiply it to by vector 1 0 1. So by this multiplication we're going to exclude the y value, as I said before. And now let's create another float variable, which we're going to call xz distance to target. So this will be like similar to the previous, but in terms of that the distance will be measured only on the xz plane. We're not calculating the y value here. So let's make it equal to length of the xz to target vector, xz to target. So we have a typo somewhere. Length to target. Yeah. And now let's change xz to target to the normalized value. And let's multiply it by the y range attribute, which we have specified here in this wrangle. So the reason why we normalize it at the end here, not here, is because we needed to calculate the distance, and we can't calculate the distance on the normalized vector. So that's why we have this normalization right here. And now let's create another vector, and let's call it dir blend for direction of the dir bend. Sorry, for the direction of the bending. So we can assign it to the value of lerp function, and we're going to interpolate between xz to target and the vector on the inverse y-axis, so 0, -1, 0. And as an interpolator we are going to use a y range, but we need to fit it, so fit 0, 1, fit 0, 1, and we're going to fit the value of attribute y range, and we're going to make it go from 0 to 0.5 maybe, like this. And now if we apply this value to the normal, for example, so v at n equals the band, direction of the band, multiplied by channel ramp, and as a channel ramp value we are going to create take a y range attribute, and let's call it simply the ramp, maybe the band ramp, like this. And here let's end with the semicolon. So now we have this ramp here, and if you preview the normals of the points, you can see that we created these normals here. And how to see how it works, we need to create the some input for the second input of our wrangle. So let's create an add point at node, and here let's create one point. And if we connect this here, you won't see much of a difference, but if we apply the transform here, and if you move this point somewhere, we should see the interaction, but we don't see it. And let me see why. Alright, so I found a little typo here. So right here we need a minus instead of equal sign. So if you change this now, if you manipulate this point, you will see that the normals are updating according to the position of this point. So it already works. It is already interactive. And now we're going to use these directions to actually bend this line. So you can already see that here we're already creating some kind of an arc, but it's not quite the goal of it, but we're close to it now. And yeah, let's continue. So here let's drop another wrangle, and this is the wrangle where we will create the actual bending. So v at n times equals 0.2 for now, maybe, just to preview it like this. And yeah, let's create another vector variable called target pose, and just give me a minute, but actually I think we can copy all of these things here. Let's paste this, and now let's just add a small offset to the position. So v at p plus equals v at n times range. And yeah, we don't have the range value specified here, and that's right. So let's create it. Float range equals let's fit the value of xz distance to target, which let's clamp it from 0.3 to 1.3, and let's map it to go from 1 to 0, like this. So here you can see. Let's turn off the preview of the point and normals, and now if you manipulate this point, you can see how the interaction actually works. So now if you go to the scatter node and you know, maybe change the number to something like 100, you will obviously have more of these lines, and that's the base functionality of it for now. So another thing that we will use later, that is kind of useful to have in this node, is like to create a p-scale value, and let's make it equal to the range for now. And yeah, the next step is like we can create some mountain on these lines, so to have them like a little, you know, more randomness. I don't know, it's up to you, but I found that the amplitude of 0.015 works fine with the elements, with the small element size like 0.1 maybe. You know, it adds just a little of randomness, but just to remind you, we're not working on visuals on this. We're just creating like the functionality, like the base system and the visualization, the visual effects, and you know, all the glory I will leave it to you. So we can add a smooth node eventually to smooth out a little this noise that we already created. And yeah, now let's create a poly wire to, you know, to add some geometry to this, and wire radius, let's maybe 0.01, 0.002, something like that. And the divisions, maybe 8, maybe 6. I think we need to reverse the normals, so let's use the reverse. Up. Like this. It's already reversed. Yep. Now it is. Alright, so we can get rid of this reverse node, and now let's use our isStop attribute to, you know, to exclude the max, the highest point on the line. So let's drop another wrangle node, and here let's connect the output of this second wrangle to the first input. And let's display it for now, and here let's put a simple condition: if I at is top equals not equals to 1, then we are going to simply remove this point, remove point 0 at ptnum, like this. And so you can see that we only have for now like only the top, the last point on each line in this node. So we're going to use it to, you know, actually apply some leaves to the top of it. So we need to set the normal, because for now, you know, they point toward more toward the ground. So let's set it to I don't know, maybe 0, 0, 1 for now, like this. So it goes in one direction. We're going to use this to you know, to rotate the instanced meshes of the output of copy to points node. So let's maybe create a simple course for the flowers for now, which are going to be simple, you know, the spheres. Let's maybe put it to 0.1, maybe 0.25, like this. And let's use copy to points. Copy to points. we're going to copy this sphere to these points here, and let's turn off the visualization. And yeah, maybe something like this, maybe a little smaller, like 0.015 maybe. We can apply a color to it already. Maybe let's make it yellow for now. And yeah, as you can see, if we now, you know, merge this together just for visualization purposes, you can see that we have this nice interaction of all this entire system. If you move this point, you can see like everything updates. And you know, the cool thing about that is that we're not using any solver to do this, so it's really kind of fast, and you can preview this in the viewport in the real time. So the next thing we are going to do is yeah, add the leaves to the top of those spheres. So let's make it. Alright, so let's create a circle and let's place it on the ZX plane. We're going to use this circle as you know, as the base for the leaves of the flower. So let's change the scale to something small, like 0.02, something like this. And we don't need an interior, so let's use an open arc. And as for the divisions, you know, this will specify the number of the leaves of the flower. So if you want less, you can make like 8 maybe, but I will leave it to 12 for now. And we need to create the normals because we don't have, and this is like the most important step here, because we are going to use the normals for the orientation of the leaves itself. So let's create a wrangle node, and we can simply use the position as a normal. So v at p, v at n equals v at p, like this. As you can see, we have these normals here. And now we are going to simply copy this circle to these points that we already created here. So let's maybe organize this network a little so we won't get confused at later stages. Maybe like this for now. We can press Shift S on the keyboard if you want, you know, these connections to be more like this. And yeah, having this circle, we can now use another copy to points. We're going to copy the circle to the points that we have from the wrangle here. These are like the top parts of every line. And yeah, if you merge this for, you know, viewport now, you can see that we have this circle on top of every line, and it's oriented upward. So I think it's a little too big for now. Maybe it's like 0.002 will do the job, or 0.005, like this. 0.9 maybe. Yeah. So now we are going to create the leaves on this circle. So I think we can copy this circle that we already used. We can change this to the closed arc for now, and let's use a reverse node to reverse the normals, and maybe transform to, you know, give it a little of a kind of a shape. So let's scale it on the Z axis, maybe like this, and on the X a little. And let's move it like this. So so the pivot is at the center here, at the beginning of the leaf. And you know, I'm making, you know, kind of primitive shapes, but because, as I said, the visuals are up to you. You can make something more beautiful, spend more time on it. But for now, yeah, we're going to use this as a leaf for the base of the system. And now we need to, you know, copy these leaves to this circle that we already created, but we need to also create the system of blossoming, you know, of opening the flower that is near the target. So to do that, we need to add another wrangle here, and in this wrangle we also need the target connected to the second input, so like this. And in this wrangle we can take all the values from this node, but this will be like yeah, like this. Let's copy this, paste it here, and I don't think we need this. And let's update the normal for now. So via10 equals, we're going to interpolate between up vector 0, 1, 0 and current normal. And as an interpolator we're going to use the range, but with slight offset, like 0.1 maybe. And we are going to also update the p-scale. F at p-scale equals 0.5 plus, let's randomize a little, like something like rand at ptnum. And I think that's it for now. So now we need to basically use copy to points, and let's try to copy the leaves into this system and see how it works. You can see something is happening, but it's kind of something is off, so I need to investigate this. Alright, so I forgot to normalize the normal creation on this circle, so we need to use a normalize function and everything should work properly. I think that the flowers are a little too big for now, so let's change it a little. But yeah, let's drop another transform because we are already, you know, above the pivot point, so something like this. There's also a problem with one leaf I see, but I will investigate in a minute. For now, let's, you know, focus on the big system, but it's definitely some issue here. So let's have this in mind. And now if we connect this to the main chain here, we should have it like this. And maybe let's change the grid size to 2 by 2. And yeah, looks like everything works. So maybe let's apply some color to this. So let's drop a color node. But before this, in this wrangle, let's create some attributes. So maybe let's call it simply color, and let's use simply the random number from ptnum. And we're going to use this on the color node. So here, color type, let's change this to ram from attribute, and attribute will be color that we already created. And here, yeah, I will make it like something like blue, like this maybe. So I will change the background to dark to see how it looks like. and let's manipulate, or let's change the position of our manipulator, and you can see that it already works. So let's go back and let's investigate why we have this issue with this one leaf. Alright, so to fix this issue you can go back to the circle that is, you know, the base for the leaves. And the issue is that, you know, one of the leaves was like really close to, you know, to 360 degree of the circle on the normal, and that caused that this leaf will flip basically its side, because we are using normals to orientation. So to fix that, you can go here and add, you know, slight rotation on the y-axis, something small like -5, -10 maybe, like this. So you can see now we don't have these leaves reversed. So now if we, you know, make the color back, and maybe one thing, we need to add a color to our lines. So let's make something green, a little darker, like this maybe. So if we merge it now, it looks like this. Maybe let's go to the wire let's increase the thickness like this, and you know, you can go to the leaves itself and make it a little bigger if you want. Something like this maybe. You know, you can really experiment with the shapes. I will leave it to you. But yeah, maybe add slight offset here. But yeah, for now I think we can merge this with our grid here, like this. Maybe we can add some color here, something dark, I don't know, just, you know, to visualize things. Yeah, and we can increase the number easily now. So if you want to go, you know, really high, you can go something like 500, but you know, there will be a lot of them. So let's maybe do 200 for now. And yeah, the cool things now is that you can, you know, place this controller whenever you want, and you can easily animate this, and you know, you can have procedural blossoming system that will, you know, maybe react to light or something like that. So here you can see that we can maybe go to the, you know, top view, and let's animate this controller to go from this point. Let's add a keyframe, and at 72 let's, you know, let's make it cross this plane like this. So now if we go back like here, you can see the blossoming actually. So you can really, you know, experiment with this. You can definitely improve how the flowers actually look like, because, you know, these are kind of primitive shapes, but yeah, you have the base, you have the functionality. If you want to, you know, improve the flowers, you know where to go. You can go to the leaves here and improve the shapes of those primitives, or use you know, some of your own, and definitely you can apply some textures to it, make it shine, and the same goes for the lines as well. You can add the leaves to this, and yeah, I think that's it for me. I hope you learned something new, and see you again.